Hello, everyone. Good morning, good afternoon, good evening, and welcome to this webinar on how to solve remainders questions. My name is Rajat Payal. I'm one of the co-founders of eGMAT, and I'm going to be your main host today. So first of all, I want to thank GMAT Club for organizing these webinars and helping us reach out to you guys. It takes a lot of effort to organize these webinars, and I think it benefits the community a whole lot. So without any further ado, if you guys can tell me if you can hear me clearly, that'd be great. Select yes if you can hear me clearly. Or rather, type in yes if you can hear me clearly. If the audio is coming through loud and clear, that'd be great.
Rajat, just one question. So can you just move this status bar? It is on the screen.
Which one? Over here.
Do you see the StreamYard?
Oh yeah. Stop sharing. This one. Yes, I can move this here. Perfect. Thank you. Thanks, Abhijit. Okay, and with that, let me get back to our view. Somehow I've lost my mouse pointer, guys. Just give me 1 second. Over here. Yes, I got it back. Thank you. All right, so the audio is loud and clear. All right, so with that, let's just move forward with the session. I'm going to actually, this is a move slide. So if you guys want to connect with me on LinkedIn, you can just search for me, or I can share a link for you to connect with me on LinkedIn over here. Just give me 1 second. And again, you can connect with upwards of 15,000 students who are connected with me on LinkedIn. So essentially, this is a fairly long session. We're going to do this session in 3 different stages. And in each of these stages, we will actually use this remainder equation, which is dividend is equal to divisor times quotient plus remainder. So we're going to just leverage this equation. Using this equation, we're going to solve the easiest to the most challenging questions. So my goal really is to teach you some key concepts that are related to this equation. These concepts are derived from this equation. So the concepts are around the addition and multiplication of remainders as well as negative remainders. And then we're going to solve about 15 questions during this webinar, during the session. It's a fairly long session overall. Now, to do this session properly, we want to make sure that you guys get feedback that's personalized to you, that you can really use to improve. And by the end of the session, you should feel very comfortable about answering remainders questions. And there are 2 or 3 things that you should take away. One is that when it comes to solving questions on the GMAT and difficult questions on the GMAT, it's not about the math, but it's logic. The second is, if you apply the process, you can solve the easiest to the most challenging questions. And the third thing, which is there, is that, hey, you've got to solve questions in a certain sequence to achieve that level of mastery overall. So with that, let me just walk you through the progress of this session. So we're going to solve some data sufficiency questions, 700 questions. So these questions over here that we're going to solve, hold on. Let me just get in my pen. These questions that we're going to solve are our holy grail. And so this is what we want to be able to build our ability to. And so I'm going to give you these questions so you know what is it that we are aiming for. Then we're going to solve some warm-up questions. And these are questions which would help us understand this remainders equation that we talked about. We apply this remainders equation. Then we're going to solve some problem-solving questions, which are over here. They're going to be 600 level. Then we're going to solve some 700 level problem solving questions. And then we're going to come back to these questions. So essentially, these questions will come back over here, and we'll really see, okay, we'll have some stats from when we solve these questions here, and then we'll see the improvement in these stats as we solve the same set of questions. So that way you will have some sort of benchmark to say how much you guys have improved during the course of the session. And post this, we'll also talk about what is it that you can do next. So again, how many questions are there in each stage and what are they called? You can really see these questions here. And overall, if you do the math, 5 plus 3 plus 4 plus 3. So it's going to be about 15 questions across. And of course, these 3 questions are the questions that we're going to solve again, because these 3 are the same questions that you see over here. Now, to make this organized, to keep this organized, we will solve. I don't want your answers in the chat pod. I want your answers in the poll over here. So I'm going to share some poll links. I've created those poll links, and I'm going to share these poll links in the chat pod. Use those poll links to solve these questions. Is that clear to everyone? So that, please type in yes so that I can proceed. All right, if I can get a few yeses, that way I'd be able to proceed. Over here, perfect. I'm starting to get a few yeses over here. With that, here is your first data sufficiency question. And I'm going to share the link with you over here. Just give me 1 second. And again, please make sure, I mean, these links, they already have the question in there, so you don't really need to refer to the presentation for questions. So with that, here is the first question, and the link to the question is there. So good luck, guys. I'm going to give you about 2.5 minutes to solve this. I have about 8 responses so far. I'm going to wait. So you don't need to say done. I get the responses right away. Let's wait for another 35 to 40 seconds. That way we give everyone an opportunity to post in their responses. About 100 students here with me. So let's get to about 30, 35 responses at least. So we have about 12 responses so far. So 25 responses, last 10 seconds. Let's get those answers in. 3, 2, and 1. Okay, with that, let's move on to the next question. I'm going to post question 9, the poll for question 9 over here. Here is the poll for question 9. Please put in your responses over here. So good luck, guys. Okay, I have 15 responses for question 9. Let's get those answers in. And Lipsa, please do not post your response over here. You're influencing others' responses. Please, you submitted your response in the poll question, and we'll discuss that. So with that, I have about 18 responses now. Let's get to 30 once again, and then we'll proceed to the next one. I understand some of you are done, but this is a session in which we have 100 folks over here. Let's make sure that we appreciate everyone who's taking time out to be with us today. All right, we have 30 responses for question number 9. Let's move to question number 10 right now. And let's get the poll for question 10 over here. Here is, and thank you, Sayan, for the appreciation. And there's the poll for question 10, and here is the question. Again, the poll also has the question in it, so you don't need to refer to YouTube to get the question in there. So yeah. All right, guys, let's get a few more responses. I have about 8 responses to question 10. I have 97 people here in the webinar. You guys are here to learn. The best way to learn is to get feedback. The best way to get feedback is to put a stake in the ground. So let's put a stake in the ground. Let's get some more responses so that we all can get feedback that's personalized to us. We all can know if you're doing things right, that we're truly doing them right, and if you're making a mistake, where we make a mistake. So just as a clarification, it seems it's not coming on properly on your screen. Statement 1 is k is equal to n times n. So n star m, so n multiplied by n, where n and m are consecutive integers greater than 0. So just to make sure, yeah. I think it's just when the PowerPoint goes and it's translated by Google into an image, it eats up some parts of it. So the poll says that clearly. So I think you should be able to get that. I have 20 responses for this question. Let's get 10 more responses. All right, another 10 seconds. 5, 4, 3, 2, and 1. Let's get those answers in. Perfect. All right, so we have the responses right now, and let me share the screen with you over here, and I'm going to share my screen, and let's make sure we get the right screen in there as we do that. Yes, so we are. So let's see how you guys did, and these are all the questions that we'll do. This was our question number 8. We got 31 responses for it. Let's see how the responses were. As you guys can really see, 20 of you chose statement 1, and then this next most popular choice was choice C as well. So choice A and choice C, both of them were very popular. Let's go back over here to our forms and question 9. Let's look at responses. Question 9, choice A was popular, choice C was popular, or so was choice D, and we had a significant number of responses for choices B and E as well. And let's go to question number 10 over here. Question number 10. For some reason, I think I need to refresh this because we had responses. Yes, we have 29 responses. You can see the average time to complete. And you can see choice D was the most popular one. About 40% of you chose choice D over here. Actually, yeah, 41% chose choice D. And then the other responses were quite popular as well. So with that, let's just go right into the webinar. So this is our holy grail. This is what we want to build up to. And we want to make sure that when we solve these questions again, we actually do a better job. We want to get more of these questions correct. And we want to be confident that we get them right. Okay. Now, each of these questions uses a bunch of process skills, and we've posted some free videos on various process skills. They are on our YouTube channel. If you want to go take a look at these skills over here, you can do that by going to this link. So with that, let's start off with warm-up section. So in this section, we're going to solve some very basic questions on divisibility and remainders. And these questions are questions that most of you should be able to answer correctly. If you're in this session, you should have the foundation to be able to answer them properly. This will give you feedback about where you currently are with regards to just the core concept piece, not the ability to apply, but the core concepts. And we're not going to discuss these solutions in details. In fact, I'm going to give you about 60 seconds to answer each one of these questions. And the idea really is to brush up some knowledge that you may have otherwise forgotten. Okay, so with that, let's start with our first question over here. And here is the first question, warm-up question, the link to that. And here is the question itself. So you have 3 choices in this one. Okay, another 10 seconds. Let's get those answers in. 5, 4, 3, 2, and 1. So very quickly, got about 15 odd responses. I think pretty much all of them were correct. Warm-up question over here. So it's about 76% of those responses were correct. So essentially what this question says is Z is a 3-digit number whose digits are consecutive integers. And that's the key piece over here. And we've got to figure out which of these statements is correct. And when you look at these statements, you say, hey, all of these are about 3 over here. So we talk about the divisibility rule for 3. What is the divisibility rule for 3? Sum of digits should be divisible by 3. Let's take the 3 digits as x plus 1, and x plus 2, which means if you look at the sum of those digits, it's 3x plus 3. You take 3 common, which means it's 3 times a number, which means that, hey, that number, 3 times anything is always divisible by 3. So we choose choice B, which is our correct answer overall. So that's the correct answer, but 80% of you got this right. Now with that, let's very quickly go on to the next warm-up question over here. And here is question 2. Here's question 2 for you. All right, last 15 seconds, guys. Let's get those answers in. All right, we are done with this. So let's kind of go through this over here. Very similar to the prior question. Instead of this, right now we're checking divisibility by 4. So what we say is Z is a 4-digit number whose digits are consecutive numbers. So we're checking for divisibility rule for 4. And what's the divisibility rule for 4? That the last 2 digits should be divisible by 4. This is the case in which we check, one of your process skills that we call as consider all cases. So in this one, we consider all cases to really say, hey, what are the various possibilities that exist? So one possibility is that Z could be odd. An example is Z could be 2, 3, 4, 5. The other, in this case, Z is clearly not divisible by 4. The other possibility is that Z could be even. And there are 2 possibilities here where the last 2 digits are divisible by pole by 4, and whereas or the last 2 digits, when the example over here is 3, 4, 5, 6, where 56 is divisible by 4, or where the last 2 digits are not divisible by 4. An example of that is 1, 2, 3, 4, where 34 isn't divisible by 4. So the correct answer in this is that there is a possibility that Z is divisible by 4. So choice A, which is Z may be divisible by 4. With that, let's look at our third question over here. And here is the link to question number 3. Again, these are warm-up questions, very, very easy questions over here. So the idea is for you to get 100% accuracy and for you to get warmed up so that we can get into the core of the webinar. All right, last 10 seconds. I have a good chunk of responses. 5, 4, 3, 2, and 1. Good. About 80% of you got this one right. So what does this say? It says if n leaves a remainder 3 when it's divisible by 2 or 4, what's the remainder when n is divided by 4? So the equation that we want to use is the remainder equation over here. And okay, I'm going to put the user. So we're going to use the remainder equation, and we're going to use this to find the remainder when n is divided by 4. What we want to do, we want to express n as 4p plus r. So this is what we want to express. Now we look at what's given to us. And remember, the constraint is that the remainder must be greater than or equal to 0 and less than the divisor over here. So throughout this webinar, I'm going to talk about this equation. So what's given to us? What's given is n can be expressed as 204q plus 3y because it leaves a remainder 3 when it's divisible by when it's divided by 2 or 4. So we combine this and say, okay, this is what's given to us. This is what we want to express n as. So we combine this and we say, hey, can we express 204q as 4p? And to do that, we then write 204q as 4 times 51q, which means that we express 204q in the form of 4. And when we do that, we get the remainder as 3, which is choice D, which is your correct answer over there. Okay, with that, let's kind of get to the next one. So pretty much most of you got it right. And let's get to the next one over here. I'm going to put in the poll question in about a second for this one. Here is the poll question. Should be coming in your chat. Okay, another 10 seconds. I think you guys are getting the hang of it now. You guys are getting the answers over here. So 5, 4, 3, 2, and 1. Apologies over here. And we got about 75% of you who've gotten it correct. So again, very similar to the prior question, we're going to use the remainder equation, which says, hey, dividend is divisor times quotient plus remainder. What we have to do is got to figure out what's the remainder when n is divided by 5, which means we have to express n as 5p plus r, where remainder has to be less than 5 and greater than or equal to 0. What's given to us? What's given to us is that n leaves a remainder of 6 when divided by 205, which means n can be expressed as 205q plus 6. Again, we really say this is what we want to get to. This is what we're given. So we visualize this. We actually really say, hey, 205q can be written as 5p. And again, with this, we say, hey, this means the remainder should be 6. But now remember the constraint that was there, that remainder should be less than 5. So what we do is we express 6 as 5 times 1 plus 1. And this gives us the remainder as 1, which is choice A. Okay. So about 75% of you got it right. The other 25% who could not solve it correctly, hopefully you guys know where you made a mistake now. And now let's go on to our last warm-up question over here. And I'm going to share the poll question with you while you solve this question. All right, we're truly getting the hang of it right now. Pretty much all of you got this right. This is good. Great to see. It's great to see that hey, we are improving as we solve similar questions. So again, very similar. We're going to use the remainder equation. What we have to do is got to figure out the remainder when n is divided by 8. So again, we have to express it as 8p plus r. What's given is the remainder is 12 when divided by 64. So what do? We really just do the visualization again, express 64 as 8 times 8q, where so it leads us to p being equal to 8q. And then we really say, hey, the remainder, since it has to be less than 12, we basically express 12 as 8 into 1 plus 4. Thus, we get the remainder as 4, which is choice B. Okay, so these were very easy questions, and I want to make sure that you guys are ready for the more challenging question that we're going to solve in this webinar. And what the last question told me is that you do have 200% clarity of concepts in this, in with regards to this equation. And again, if you made a mistake, figure out where you made a mistake, and then from there on, build on that. Don't repeat that mistake overall. And because what we want to get to is a much more advanced level of application with regards to the GMAT level questions. I'm also encouraged to see a much higher level of participation over here. Now, with that, let's now solve a few more questions. These ones, again, relatively simple questions, and so, but we're going to continue to apply the same remainder equation. And what you're going to really see is, as in about 20 minutes, we're going to make you solve 700 level questions using the application of the same equation. So we're going to apply the same equation and solve 700 level questions. So these questions may seem easy to you, but as we increase that difficulty level, you're going to find even those questions which seem challenging start to become easy. All right, here is the next question over here, and I'm going to share the link with you very soon. One of the other reasons I want to make sure that I see that YouTube's cutting out the equal to. So if you click on the question link, you should be able to see the question a lot more clearly. So the question says m is a positive integer and m by 15 is equal to 8.2. So it's not minus 8.2. Just want to make sure that you guys understand that. So and so if you click on the question statement, you should be able to see the question much more legibly. Okay, get those answers in. I'm going to give you another 10 seconds. 5, 4, 3, 2, and 1. All right. So again, application of remainder equation, a slightly more sophisticated application. What we have to do is we've got to find the remainder when m is divided by 30. We're given this in a decimal form. Again, the expression is very similar. We have to express an m as 30p plus r. Okay. So what's given to us is m is equal to 15 times 8.2, which means if we use the distributive property, we really say, hey, m is equal to 15 times 8 plus 15 times 0.2. Okay. So you visualize this and say, this is what we want to express this as. This is what's given to us. And so what we do is we really say, hey, let's divide this 8 into saying 15 times 2 times 4. So we divided the 8 into 2 times 4. And remember, 15 times 0.2, this got us 3 over here. So when we do that, we say, hey, 30 times 4 plus something. So m is 30 times 4 something plus 30 times 4 plus something. So 30 times a number plus something, which gives us the remainder as 3, which is choice C over here. Okay. So, so yeah. Felipe, I'd be happy to take your question 3 warm-up later on in the session. I think we're way past that. Or you'd get the PDF and you can really see that as well. Okay. So with that, here's the next question, and I'm going to share the link as well to this next question. And as was the case with the previous question, it's m by 15 equal to 9.2. Just want to make sure that that part is clear. All right, we have gotten the responses. So let me just move forward. 5, 4, 3, 2, and 1. Okay. So in this case, as you guys have correctly pointed out, the answer is E. What we have to do, we have to express M as 30p plus R, where R has to be less than 30. The remainder has to be less than the divisor and greater than or equal to 0. What's given to us? We're given M is 15 times 9.2, which means if we break it up, We can really say m is 15 times 9 plus 15 times 0.2. Now remember, we have to express m in the form of 30. So we further distribute this 9 over here, and we really just say, hey, let's 9 be 8 plus 1. That's a process skill called visualization. And so we really say, hey, m is equal to 15 times 8 plus 15 times 1 plus, again, 3. Remember, this is over here, which means it's 15 times 2 times 4. So this will give us 30 over here, 15 times 1 and 3. And so this is a term which is completely divisible by 30. So this gives a remainder of 0. So the remainder has to be the sum of these two terms, and which gives us 18, which is choice E, which is our answer over here. Now, just a quick question. How many of you actually solve this question using using this method, using the remainders equation, versus doing the math, getting to what is 15 times a 9.2 and then doing the division? How many of you actually use the remainders equation? So if you use the remainders equation, say you use the remainders equation. If you did the math, then you can say no. If you use the remainders equation, say yes, I did, yes. Or if you did not do it, then say no. For those of you who are saying no, you may be able to solve these questions correctly, but if you don't use the remainders equation, the more challenging questions, you're not building your ability towards it. Remember, you are not here to solve these questions, because frankly, these would get you to a Q40. You're here to build your ability towards much more challenging questions. And the way to build that ability is to use the remainders equation. If you don't use it, if you simply do the math, which by the way, you can get to this answer by doing the math, you'd struggle to solve the more challenging questions. So going forward, please try and use the remainders equation to solve questions. Okay, don't do the math. The whole idea here is that you don't do the math, because GMAT quant is not about math. It is about a logical approach to solving quant problems. Okay, with that, just very simple questions over here. It was purely the application of this remainders equation. We actually made these questions a bit more challenging, and you can see how over here we divided 9 as 8 plus 1 and made this more and more logical. Now we're going to go to a concept where we will talk about addition and multiplication of numbers, and in this case, what we are going to really do is, we're going to build upon this understanding of this equation overall. Okay, so let's kind of look at how we build upon this understanding over here. So let's take a simple example, and this is not a question, this is an example to explain the concept of addition of remainders. So when I say what's the remainder when 31 plus 43 is divisible by 7, there are two ways of doing this. One way is, you can really just solve this. So you say, hey, 31 plus 43 is 74, and then you do 74 by 7, and you get the remainder as 4 over here. The other way is, you really say, hey, I'm going to get the remainder of each of the individual terms. So 31 by 7 gets you the remainder 3. That's number 1 over here. And 43 by 7 gets you the remainder 1. That's number 2. You add these two, you get 3 plus 1, and you get the remainder as 4. Okay. So one way or the other, either way, in this case, you might find that either approach is good enough. You can do the addition and then get the remainder, or you can get the remainders of individual numbers first and then do the addition, and you can use your judgment as to which approach to use. Okay, now when it comes to multiplication, right, let's say the question says, what's the remainder when 31 times 43 is divided by 7? Then there are again two ways of doing this. The answer is 3. So sequence 1 is, you do the math. You do 31 times 43, you get 1333, you do the division, you get the answer as 3. This is something that I don't want you to do. This is not the right approach. I don't prefer this approach. This is something that I don't prefer. The second way of doing this is to really say, hey, let's get the remainder of individual numbers. So we do the remainder of 31 times by 7 as 3, and 43 by 7 is 1. And then let's multiply these two numbers. So you get 3 times 1. The answer is again same as 3 over here, as you can really see. So this is 3. This one was also 3. And this is my preferred approach. I would rather that you do this. Why? Because it's clearly way more efficient. And that's where I said don't do the math. Understand the logic. Now you guys are wondering, why does this approach work? And the answer is in this equation, which is why we are building up to this equation overall. So why does this work? Because this equation works. So let's kind of see why it works. So again, the same example. We really said, hey, if you want to add two numbers and want to get the remainder of those two numbers, we get their individual remainders and add them up. So let's see why that is the case. The reason why that works is because 31 is nothing but 7 times 4 plus 3, and 43 is 7 times 6 plus 1. So essentially, when you're doing 31 plus 43, you're doing 7 times 4 plus 3 and 7 times 6 plus 1, which means that this term and this term, their remainder is 0. So essentially, the sum of the remainder of the sum is essentially the sum of individual remainders over here. Now, given the same constraint that we have, which is that the remainder must be less than the divisor. Okay, so that's why the addition part works. Now let's see, why does the multiplication part works? And again, unknowing, you can really say, why? I understand how that it works. I don't want to worry about it, but you've got to understand why it works. Why? Because as questions become more difficult, sometimes you may have to just use this equation to get to the answer. Okay, and again, it's still the same equation. So remember, we said product of two numbers is the remainder of a product of two numbers is the product of individual remainders, where we got the remainder 1, remainder 2, we multiplied them, and again with the constraint that the remainder has to be less than divisor, which is 7 in this case. Okay, so how do we do this? We again express 31 as 7 times 4 plus 3. We express 43 as 7 times 6 plus 1. So when we say we want to find out the remainder of 31 times 43, what we are really saying is we want to find out the remainder of entity 1, product of entity 1 with entity 2. Or essentially, when you simplify it, you get these four terms, and you see that this term leaves a remainder 0, this term leaves a remainder 0, this term leaves a remainder 0. The only remainder is over here. Okay, so which is the product of individual remainders over here, again with that constraint. So can you guys really see how, if you understand this remainder equation, you can simplify questions that may seem complex? Can you really see how this equation empowers us to get answers? Can you see that? Yes, no? Yes, no? Let's get a few more yeses. Perfect. I can see the yeses come in. And Sayan, we're going to solve some questions using this. So with that in mind, with these in mind, so this is what we call as addition and multiplication of remainders. Let's kind of solve some questions overall. So let's see, use this, the same principle to solve this question, and I'm going to get you your form over here. Here is your poll. All right, I have about 15 responses. I'm going to give you guys another 10 seconds to get those answers in. Wow, 20, 25, 23. Cool. So again, from the multiplicative property, we get the remainder of the product is the product of individual remainders, where we express 91 as 3 times 30 plus 1, 202 as 3 times 67 plus 1. So we get their individual remainders as 1 and 1. And then from there on, we really say 1 times 1 is 1. And choice B is my correct answer over here. All right. So with that in place, let's kind of look at the next one. So here is the next question. Let's get to these answers. And please, as Shweta is saying, let's not put answers in chat. How about this link? Let me know if this one works. Yep, this one's the right link. Cool. All right, we're starting to get responses. That is great. Perfect. Let me see, 23. All right, let's move forward. So how do we go about doing this? We really say, and then again, so we've been asked, what's the remainder when 25 times 38 to the power 3 is divided by 3? So we can write this as a product of three numbers where each number is 25 times 38, 25 times 38, and 25 times 38. Okay, so let's call this 1, 2, and 3. And we can really find the remainder of each term, and then their individual remainders can be multiplied. All right, and because they're all like terms, we essentially can say the remainders will be the same, so we can purely cube that remainder. So let's find the remainder of 25 times 38, which would be the individual remainder of 25 by 3 multiplied by 38 by 3. So 25 by 3 gives me a remainder of 1. Okay, so that's the remainder of this is 1 over here. The remainder of this is 2. Okay, so that's 1 times 2 to the power 3. So because it's 1 times 2 to the power 3, we really get 2 to the power 3, which is 8. But then remember, the constraint is that the remainder has to be less than 3. So we express 8 as 3 times 2 plus 2 over here. And we get choice C as the correct answer. Okay, so how are we feeling so far? How are we feeling so far? Good, not so sure. I mean, are we seeing the momentum build up? Cool. These are starting to get towards those 700 level questions. Yes, Niyal. And you can really see this is not so much about math than logic overall. So yes. And it's all about building that ability from really the basics to getting towards more challenging questions. So that's what we want to get to. So now we want to talk about another concept. which is negative remainders. But let's kind of review this. So these are some 700 level PS questions in 4 and 5. What we did was that, hey, when you talk about the remainder of a sum, it is equal to the sum of individual remainders, which is what we said. So we can really find 1 and 2 over here and add that up, and we applied that. And a product of remainders is essentially the remainder of a product, which is this part over here. This is the remainder of a product, is product of individual remainders over here. Okay, now let's move forward and build upon this. And again, we say when we have powers, we extended this to powers and said, let's find when we want to do 31 to the power 3 by 7, we do the remainder of 31 by 7 and then cube that piece. Okay, so that's the simplification. Now we want to talk about another concept called negative remainders. And this is a concept which again is a simplification method, which allows us to find the remainder when positive remainders or when expressing a number as x minus something is a much more easy math overall. So let's kind of look at this. So again, it all stems from our ability to represent a dividend as divisor times quotient plus remainder. That's the equation that we're going to focus on throughout this session. Okay, where the remainder has to be less than the divisor and it always has to be non-negative. So when we say greater than or equal to 0, it means it is non-negative. So there are two ways to, and to really do a very simple example over here, we can say, hey, 5 divided by 2 is 1. The way to really figure that out, that the remainder of 5 by 2 is 1, is we can express 5 as 2 times 2 plus 1. Or 8 by 3 is, the remainder is 2. Why? Because 8 can be expressed as 3 times 2 plus 2. I want you to get into that habit of expression of a number when you're dealing with a remainders question. Now this works, we know that. But sometimes we want to really write it slightly differently because it's better. So we may want to really write 5 as 6 minus 1 or 2 times 3 minus 1. And we want to write 8 as 8 times 9 minus 1 or 3 times 3 minus 1. So when we do that, we get these remainders called as minus 1 and minus 1 in each of these cases. And these are what we call as negative remainders. But we know that a remainder can never be negative. It always has to be non-negative. So how do we find a positive remainder if we want to express our dividend in this form? And that's what we're going to look at. And again, the reason why we're looking at it is because sometimes they help us get to the answer in a much more simplified fashion. Okay, but these are what we call as negative remainders. We're going to really see how we convert a negative remainder to a positive remainder. Okay, so we got these negative remainders in this case, and we applied constraints. And again, see how we use this remainder equation to apply at this this method. Again, why are we worrying about negative remainders? Because it can, in certain scenarios, and we're going to look at those scenarios, it'll lead us, it'll make processing or math a lot easier. It'll actually help us avoid the math overall. And it'll give us some time back. It'll help us improve our accuracy as well. So since a remainder cannot be negative, we have to convert this negative remainder to a positive remainder. So how do we go about doing that? Okay, we add and subtract the divisor over here. So we really say, hey, let's, in this case, remember we were doing 5 by 2 over here. So we add plus 2 and we subtract minus 2. We're essentially adding 0 over here. So we rearrange the terms. We take this minus 2 and bring this over here. And we say 2 times 3 minus 2. And then we take this minus 1 and take it with plus 2. And essentially, you can say 2 times 3 minus 1 plus 2. Or in other words, we can really say 2 times 2 plus 1. So this remainder over here now becomes a positive remainder. Okay. Same thing with 8. Let's just, so we get the same remainder as 1, which is what we got over here. So what is your, if you express something as a negative remainder, what is the remainder? If the remainder is negative, you add that divisor back to it. So in this case, we got minus 1 over here. We added the divisor back, which is 2, and you say minus 1 plus 2. That's your positive remainder. Okay. And The same thing with 8. We express 8 as 3 times 3 minus 1, and then we add a plus 3 and subtract a minus 3. So we are essentially adding 0. Then we rearrange the terms and we say, hey, 8 can be expressed as 3 times 3 minus 3. And then we take this minus 1 and we take this plus 3 and we combine them. And as we do that, what we get is 3 as common over here between these two terms. Between these two terms, we get 3 times 3 minus 1, and then we get minus 1 plus 3. So we get the same remainder as 2. So again, in case a remainder is negative, you add the divisor back to it to get your positive remainder. Okay. So that's the way to use negative remainders to your advantage. Now let's kind of apply this method to solve some questions. Okay. So again, the key to remember is this positive remainder is negative remainder. In case you find the remainder is negative, negative remainder plus divisor. So let's solve some questions over here. Here's the first question that we're going to solve, which is what's the remainder when 24 to the power 3 multiplied by this is divided by 3. I'm going to give you your form to post your answer in. And again, this concept will become very clear. We're going to solve two questions using this concept. So it's going to become very clear. So don't worry if it's slightly hazy for you. Perfect. Guys, please don't post your answers here. I am getting the answers in forms. So let's get those answers over here. I'm going to give you another 10 seconds to get to the correct answer over here. 5, 4, 3, 2, and 1. So let's see how we go about doing this. So what we are asked is, what's the remainder of this complex expression when this sum of two numbers is divided by 3? So we have got to find the remainder for this entity over here. So we say, hey, a remainder of a sum is essentially the sum of individual remainders. So we divide this over here, and this term, has a remainder of 0. Why? Because 24 is completely divisible by 3. So essentially, we only have a remainder from 17 to the power 7 divided by 3. Okay. So let's kind of figure out how do we find the remainder as 17 from 17 to the power 7 divided by 3. There are two ways of doing it. We can express 17 as 3 times 6 minus 1, or we can express 17 as 3 times 5 plus 2. This is the way to do negative remainders, and this is the way, to do positive remainders. Okay. So we clearly, this part seems to be much more efficient. So we start the processing with negative remainders, and we get the remainder as minus 1 to the power 7, which is minus 1. And we say, man, this was a negative remainder, and we know the remainder can't be negative. So what do? We add our divisor back to it to convert it to a positive remainder, and we get the answer as 2. Now, if we can also do it using positive remainders. We can really say, hey, 2 to the power 7 is equal to 128, which is the same as 3 times, I think the answer is 42. 42 plus 2, which means that the remainder is 2 over here again. But again, positive remainder, the processing becomes a bit more challenging. Negative remainder, it's a lot easier over here. So this is the path that I would prefer. Now, can you guys see how negative remainder saves us time over here? Can you see that? How negative remainder makes solving a question such as this one a lot more efficient. Yes, no? Yeah, perfect. Let's get a few more yeses over here, and then we'll move forward. So we're going to now solve another question using negative remainders. And the next one is going to be very difficult to solve using positive remainders. So I want you to focus on applying negative remainders. And here is the next question. Again, the same expression, but we are now dividing by 6. If it's not loading, you can. I've also shared the other link, the link without the bit.ly. Perfect. So I have enough responses over here. Okay. So again, very similar, the same expression. What's the remainder when this complex looking expression is divided by 6? Again, we start with the same thing and we say sum of a remainder of sum is equal to sum of remainders. We know that this part will leave a remainder of 0. So we have to focus on this term over here. Okay. So we express 17 as 6 into 3 minus 1. So 18 minus 1. Why? Because this part over here is very complex. So we get the remainder as minus 1 to the power 7, which is minus 1, which is a negative remainder. In that case, we add the divisor back and we get the answer as 5, which is choice E. Okay. So that's how we do this. Now, can you tell me if instead of this term being 17, if this were 19 to the power 7, what would my answer have been? Can you type that answer in over here? If this were 19 to the power 7, my answer would have been, if you want to type the answer here, plus 1, correct, yes. You would have used the positive remainders. No, because you would get the positive remainder. So 19 to the power 7 would have been 18 plus 1 is what you would have expressed, or you would have expressed 6 times 3 plus 1 to the power 7, which means you'd say plus 1 to the power 7, which is equal to plus 1. Since this remainder is already positive, you don't need to add back your divisor. So the answer is plus 1 over here. Okay. Now let's look at another one over here. Okay. What if this were 20 to the power 7? What if this were 20 to the power 7? What would the answer be? Let's just take a few scenarios. Okay. Let's 20 to the power 7. All right, we are now getting the answers. That's great. You guys are getting this. So 20, we would express that as 6 times 3 plus 2 to the power 7. Remember 18 plus 2. So we would get 2 to the power 7, which is 128. So 128 can be expressed as, so 128, sorry, let me just erase this. 128 can be expressed as 6 times 21 plus 2, which will give the remainder as plus 2. Okay. So you're now getting the hang of it. You want to do one more along those lines? You guys want to do one more? Yeah, hold on. Let me just look at the time. We have 10:15. So I think we have 3 more DS questions that we need to do. So let's kind of move forward over here and let's do those DS questions. So now you guys know the concept very well. So so we will move to solving data sufficiency questions. Okay. It does work for subtraction cases as well. Yes. So again, let's go back to the 700 level data sufficiency questions. And again, these are the same questions that you guys solved earlier. And I'm going to show these questions to you. And I'm going to put in the bit.ly links over here. So here is the question. Here is the link. I'm going to mute myself for about a minute and I'll be back. All right, guys, let me get the link. Just give me 1 second. The link should work. Just give me share, copy, and let's get this part over here. How about now? Perfect. Thank you. Let's get those answers in. Cool. I am getting really good responses to this one. I am so glad to see this. All right, 3, 2. Let's get a few more responses, guys. 3, 2, and 1. Let me end the poll. Oh, you can't end the poll over here, but let's just go discuss this question. So this is a data sufficiency question, and the question is asking what's the remainder when a positive integer p, okay, is divided by a positive integer m, where m is greater than 1. All right. So we have to figure out what's the remainder when p of p by m is not a whole lot that's given to us. Okay, and what we're given is that m is greater than 1, and both m and p are positive integers. So statement 1 says m is equal to p is equal to m plus 1 to the power 8. So again, what we do is we say, hey, if p is equal to m plus 1 to the power 8, we really divide both sides by m, and we say p by m is equal to m plus 1 to the power 8 divided by m, and we have to find the remainder of this. Looking at the multiplicative property, which means that the remainder of this is m plus 1 to the power 8 divided by m. We know m by m doesn't leave a remainder. 1 by m, given that m is greater than 1, will leave a remainder of 1, which means the remainder of the expression will be 1 to the power 8, which is a definitive answer. We get to the answer over here. Okay, so the answer can be found. Statement 1 is sufficient. So with this, we can really say since statement 1 is sufficient, we can say the answer could be either choice A or choice D, where choice A is only statement 1 is sufficient, choice D is either statement is sufficient. Now let's do statement 2 analysis. Statement 2 says m is equal to 8. It doesn't give us anything about p. Since p could be anything, we can't really figure anything out because of it, which means statement 2 is not sufficient, which gives us choice A as the correct answer. Now you can really see how we use the concepts that we learned over here to solve this difficult question. And this seemed like a difficult question, but it really was not a difficult question overall. So how do you feel about this? How do you feel about this right now? Let me just get. Is this? Can you really see how we are able to apply this and get to this to answers to difficult questions? Now, if you want to learn how to assess yourself, then we have an assessment that we're doing this Sunday. It's a quant workshop, which you can register for over here. In this, we'll assess you in all aspects of quant, give you feedback that's personalized to your strengths and weaknesses, so you can build your own quant study plan. So you can click on this link over here and register for the same. Okay. Again, the concept that we used in this is nothing new. We've used this concept again over here. We're going to apply the same concept in the next question as well, where it'll get slightly more challenging. Now, the beauty of data sufficiency questions is that you kind of start to get some of these basic concepts from other aspects In this case, actually, it's not even other aspects. It's even odd that we're going to get more concepts from, and 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 you get to do a lot better. And if you like what you're learning over here, press the like button so that you let GMAT Club know of the same. Now, with that, let's kind of go to our next question over here and start solving it. I'm going to give you the response, the poll for next question. All right, another 15 seconds, guys. Let's get those answers in. So 5, 4, 3, 2, and 1. So we got what I call as a split jury. We did not get that we did not get that convincing number of people who say 80% of you got it right. No, we got only 6 of you who I think got it right. So let's kind of see how we go about solving this question, and then at the end of this question, once we go through the analysis, I want you to tell me where you faltered. And so this is a classic example of where we take what we've learned in remainders, and we apply this we bring in knowledge from other aspects of number properties to put in over here. And most likely where you faltered is not because of remainders, but because of the lack of knowledge that you have from other aspects. And this is where I think I want to make sure that you give yourself that feedback as to if you faltered, where you faltered. So let's see this. What this question tells us is that n is a positive integer. What's the remainder when 38 to the power n square is divided by 13? So the first thing when I look at this is to say, hey, it's 38 and it's 13, which means it has to be close to 39, which means I'm going to use the concept of negative remainders. Okay. So what do we have to find? We have to find the remainder of 38 to the power n square when that number is divided by 13. All right. So what do we do? The first thing we do is we express 38 as 13 times 3 minus 1. All right. So then we can also express 38 as 13 times 2 plus 12, but that lead to an issue. We don't want to get there. It's division by 12 isn't so great. So when we do this, the remainder really is minus 1 to the power n square. Now this leads to two cases. One is if n is odd. If n is odd, which means, and the second is if n is even. Okay, why? Because square of an odd number is odd, square of an even number is even. So when you think about 3 square, it's 9. When you think about 4 square, it's 16. So if n is odd, my remainder is going to be 12. Why? Because I'll get minus 1, and then I'll have to add the divisor back to get to a positive remainder. If n is even, my remainder is going to be plus 1. Now, how many of you were able to get to this simplification? This is simplification on the original information that's given to us. Remember, we've not even gotten to really statement 1 or statement 2. How many of you were able to get to this level of simplification? This is what we call as simplifying. So the process skill piece that we talked about earlier, and which, by the way, is very useful if you want to get to, if you want to be able to answer 700 level questions, we talk about this process skill of simplification over here. So, so again, if you haven't looked at that YouTube channel, take a look at the process skills. There are about 40 odd videos over there that you can learn. Okay. Now, that's something that you can now look at. So if you did this, give yourself a pat on the back. You did the divisibility piece right. And then also tell yourself that even though you did the 700 level divisibility piece right, because you lacked basics in other areas, you still got it wrong if you did indeed get it wrong. Okay, so let's analyze statement 1 now. So statement 1 says that n leaves no remainder when divided by 4. So this means n is equal to 4k, which means n is even. And if n is even, we know case 2 remainder is a definitive plus 1. So statement 1 definitely is sufficient. Okay. Let's kind of look at statement 2. Statement 2 says that square root of n is only divisible by 1 in itself. Now, which means that square root of n is a prime number. Why? Because only a prime number is only divisible by 1 in itself, which means that n is actually a square of a prime number. Because n is a square of a prime number, n could be 2 square or 3 square or 5 square or 7 square, which means n could either be even or n could be odd. Now, if in the case that n is even, we know that the remainder is plus 1. In case that n is odd, we know the remainder is 12. So we can't get to a definitive answer with regards to the remainder over here. And hence, statement 2 is not sufficient. Which means my answer choice is choice A over here. This is my correct answer, choice A. Now, where did you guys falter in this? You got the second statement wrong. Okay, Lisa, what else? What is Z, Lisa, over here? I don't see a Z in this entire question. Lipsa, sorry, Lipsa. No, statement 2 equates that n is a prime number, or n is a square of a prime number. That's what statement 2 equates to. Okay. Okay, you thought n is a prime number, but Okay, didn't connect the tops. Yes. Second statement is wrong. You came to the conclusion that n is 1. Okay. When you really say n is only divisible by 1 in itself, you got the wrong conclusion from this over here. So again, you can see the feedback over here, Yashodha, that again, this is where you faltered. It's about inferring information that's given to you, which is also a process skill. Okay, you did the math part, you got it right. It's just the logic part where it comes to inferring information in this one piece, which is where you made a mistake. And this is the feedback that you need to tell yourself so that uh, going forward, you don't make the same mistake. Now, one other thing, how many of you need help in reading comprehension? How many of you need help in reading comprehension over here before we go towards the last question for the day? We have an upcoming webinar in reading comprehension, which you can register for over here. So if you want to, you can register for that over here. So how do you improve your inference abilities? Look at the process skills link that I shared earlier, and that's how you'd be able to improve your inference abilities. Let me share the quant process skills again. We have some excellent questions over there. Here is the quant process, this link to quant process skills. It should appear in your chat fairly soon. So, and I'm going to share the PDF with you. So you're going to really see that. Again, remember, there's a lot of information you guys have absorbed in this webinar. I mean, you've gone from the very, very simplest concept to probably the most challenging questions that the test is going to throw at you. So it's natural that you're not going to get certain things, but once you revise, you would get them. So okay. So with that, let's do the last question for the day again. And I'm going to get you the form for this particular question. Here is the form to this particular question. And once again, please see the question. Please look at the question over there. Don't look at the slide, because this one should really say k is equal to nm, where it's n multiplied by n. This is n multiplied by m over here. Just want to make sure I confirm that piece, because YouTube's killing that. So it's n multiplied by m over here. Okay, guys, another 15 seconds. Let's get those answers in over here. Um, Five, 4, 3, 2, and 1. Now, this is a 700 level question, and about 70% of you got this right. 70%. And that's for me, that's amazing. I mean, um, the fact that you guys can get a question such as this right. So let's kind of solve this. So what's given to us is k is a positive integer, and what's the remainder when 62 to the power k to the power 3 plus 64 to the power k to the power 4 is divided by 7. Okay, so you can look at this and say, man, this is really close to 6 raised. So let's analyze the original statement. The correct answer is choice D, as many of you are saying. Okay, and really just look at this over here and say, hey, let's focus on 62 to the power k to the power 3. And I'm going to express that as 63 minus 1 to the power k to the power 3. Yes, these are the same questions, Lavesh. Now, with this new knowledge, you can really see the accuracy is much higher. So, what are the cases over here? So the remainder of this is going to be what? Hold on, my bad. Why did it go back? What's the remainder of this going to be? This is going to be minus 1 whole to the power k cube, which could either be minus 1 if k cube is k cube is odd, which means that I'll have this as a negative remainder, which means I'll have to add plus 7, so it'll be plus 6 over here. So that's one way. So it could, or it would be plus 1. So option 1 is it could be plus 6, or the other way be it could be plus 1 over here if k cube is even, which means, hey, k is even. Okay, this implies k is odd. How many of you were able to get to this part over here? There is a 60 to the power k cube. The remainder would either be plus 6 or plus 1, depending on whether k is even or k is odd. How many of you were able to get to this? Yes, no? Perfect. And similarly, the remainder for 64 to the power k to the power 4 was going to be 63 plus 1 to the power k to the power 4 over here, which means it's always going to be plus 1. So this one is always going to be plus 1. There's no negative remainder. Why? Because we have a plus 1 over here. So again, what we have to figure out is k even or is k odd? All right. So that's my original statement analysis. That's the only thing that we have to figure out. Okay, let's look at statement 1. Statement 1 says k is equal to nm, n times m, where n comma m are consecutive integers which are greater than 1. All right, consecutive integers greater than 1. So what could n be? Let's kind of consider cases. N could be 2 and m could be 3, which means n times m is going to be 6. N could be 3 and m could be 4, which means n times m could be 12. In either case, in any case, one of n or m would be even, which means n times n would always be even, which means k. This implies k is equal to even. We have a definitive answer, which means statement 1 is enough. Which means my answer is going to be either A or D. Okay. How many of you were able to get to this? How many of you were able to get to this? Or which is, as Shailene says, odd times even or even times odd. Yes. And then statement 2 says k cube is divided by 8 square, the remainder, which means that k has to be even. Okay, which means if k is even, which means this is sufficient too, which means the answer is not A, but choice D, that either statement by itself is sufficient. Right? So 800, 700 level question, easily answered. 70% of you got this right. Now, how are we feeling so far? Time, and again, my apologies for this. For that, I clarified that over there, but I think you missed that. I clarified while you were solving the question. But hopefully, you guys are feeling good. Hopefully, you guys believe in this mantra that hey, GMAT Quant is not about being really good in math. GMAT Quant is essentially about mastering the process and not doing the math. That's something that I want to make sure that you guys really take away from this, that it's about mastering that process overall. And once you master that process, you are able to solve the most challenging questions. I mean, managers don't need to be good at math. They need to be able to comprehend numbers that are there. Okay. So let's kind of look at how people have used this to improve beyond a certain point. Here's an example of a student who actually went from a Q48 to a Q51. Now, this guy was really good at quant always. So for him, the math part was not the problem. The problem was him faltering in data sufficiency questions. And he was doing the math rather than focusing on using the logic. The moment he stopped you doing the math and started focusing on using the logic, what he figured out was that it was a lot easier to get to solve questions, and he was able to get to a Q51. Again, if you're at Q48, stuck at Q48, ask yourself, are you doing the math? Here's a guy who actually improved from a Q45 to a Q49, got into Wharton over here. You can download this over here. So this guy was unable to get to a Q45, beyond a Q45, despite having spent a lot of time. So what helped him improve? One is, again, not doing the math, but focusing on the process skills that we've talked about. The second is to look at where he or she needs help. All right. So look at analytics to see where this particular student needs help over there. And then he did selective practice. So he actually looked at only those areas where he needed help, looked at the solutions, learned from the solutions, understood, built his process skills over here. And again, this guy got into Stern, Tepper, and Wharton. He's currently studying at Wharton overall. Now, where do you get the quant skills over here? So if you want to get to eGMAT free trial, we have them in the free trial. You can get them over here. This is where you'll get the remainder tutorials. Okay, here's a guy who went from a really low score in quant to a Q45, and again for him the key over here was to start with the with the right difficulty level. I mean, this guy was trying to solve all difficult questions without mastering the basics, which was the wrong approach to do. And for him, he started with the easy questions. He built his ability consistently and moved on to difficult questions. I think the point that I want to say is each one of you is different, and the path to improvement for each one of you is going to be different, depending on where you're starting. What you do would vary, and it's really important for you to recognize that what worked for your friend might not work for you because you are in a different place than your friend. And here's a guy who went from a Q30 to a Q50. So this is the whole gamut, going from a very low score to a very high score. Again, the guy starting at Wharton right now. Again, what helped him improve? He actually went through the entire circle, started from the very basics, started solving easy questions. He focused on learning, and obtained an accurate estimate of ability, and then he spent a long time. I mean, it took him about 3 months to get to a Q50, but because he started from the right path and he tracked his improvement, he was able to get there. I mean, think about a Wharton, someone who's starting at a Q38 to really dream about Wharton, where Wharton is a quant-focused school. And at a Q38, this seemed like a dream or a distant dream. But the key thing which is there that I want you to take away from this is that if you want to ace GMAT quant, focus on really learning and not worry about really timing or other things right away. You want to download the session PDF? Here is the session PDF. You should be able to download this over here. So some concluding remarks over here, which is make sure that you have clarity on concepts. Make sure when you read a question statement, become an active reader. I mean, one thing that I really do is I don't rush through the question statement. I read it. I translate numbers to English. And one of the process skills that you're going to see when you go to the YouTube channel is the skill to translate. The other piece is trust the test maker. GMAT's not a test of doing math. So there's some question that you can solve by doing math, but you're not required to. All right. So as long as you focus on looking at the right way of solving questions and not doing math, you're going to find that acing GMAT quant is a lot easier than what you thought it would be. And the last piece is, you're going to see these cases over here. So when I talk about this piece over here, there will be questions that would seem very difficult. Why? Because you will see exponents, you'd see fractions, and so on and so forth. And you'd say, man, this is difficult. But trust yourself that, hey, you have the skills. There will be a way to simplify a complex expression that's going to come your way. As long as you trust yourself, you're going to find acing the GMAT, it's going to be a lot more simple. With that, I want to thank you guys for joining me today. We have some really good videos in primes, divisibility, and remainders in our free trial. I sent the free trial link over there. Log into the free trial, watch those videos. We also have a few more practice questions in the PDF. I think about 6 more practice questions. Do that. And we have about 59 practice questions in Scholarium, which is our assessment platform. Do that. And good luck. With that, I'd truly appreciate some feedback on the webinar. If you could let me know how you liked it, or that'd be really good. If you have any questions, I'd be happy to take those questions as well. And I also want to thank you guys for being there. I mean, this was a long webinar, and you guys persisted for upwards of 2 hours or so. And I saw many of you were waiting prior to joining. So yeah, some feedback that'd truly be appreciated. And again, if you want to get the link to free trial, that is the link to free trial over here. Thank you, Sakshi, or Sakhi. My apologies. And yeah. And again, I look forward to seeing you guys in the RC webinar, which we have on Saturday, as well as in the quant workshop on Sunday as well. And if you guys want to reach me, you can reach me at rajat@e-gmat.com. All right. With that, I want to thank you guys for joining me today, and I look forward to seeing you on eGMAT. Bye-bye. Have a good rest of your day, and stay safe in this environment.